Hi everyone, and welcome to our class number 2 in week 13. And today we are going to talk about gases. Of course, first of all, we want to look to these slides, which is describe some common gases around us. For example, the hydrogen gas, nitrogen gas, oxygen, fluorine, and chlorine. Also, the oxides of the non-metals on the upper right corner of the periodic table, like carbon monoxide, carbon dioxide, nitrogen monoxide, nitrogen dioxide, sulfur dioxide, and sulfur trioxide. Of course, also the noble gases, which is in group 8A or group 18. That's also gases. Carbon compounds such as methane, propane, butane, all of them are examples of gases. But what is the properties of gases? We want to discuss something is called kinetic molecular theory. The gas particles, atoms, however it is atoms or molecules, are moving all the time, and they are moving rapidly in straight paths, in straight lines, and they are colliding with each other and colliding at the same time with the walls of the container. The attractive or repulsive forces between gas particles are very small because they are very far from each other. Another point, which is the properties of the gases, that the gas fill up the entire volume of the container, and that's unlike liquids and solids. So in another way, we can say that the volume of the gas equal to the volume of the container. Let's talk about this point. Since gas molecules move fast and fill the container, the gas particles can be compelled to get closer. Thereby, the volume of the gas can be compressed or can be decreased. Always when we say kinetic energy of the gas particles, we always relate it to the kinetic energy, which is related to the movement of the gas particles. Please go to the Blackboard weekly learning material, week 13, and try to practice on this simulation, which will give you an understanding of the behavior of the gases. When we are talking about the gas, we are using or we are concentrating on 4 parameters. The first one is the pressure, which gives the symbol P. The pressure is the force exerted by the gas on the walls of the container. So when the gas is moving fast, the gas molecules collide with the walls, and that causes the pressure. The volume, which gives the letter V, the space occupied by the gas, and that's measured in liter or milliliter, while the pressure will be measured in the unit atmospheric pressure or millimeter mercury or Pascal. The temperature, which is given the letter T, and this is the factor that determines the kinetic energy, the movement of the particles, and the rate of the motion of the gas particles. And we are going to use 2 units for the temperature: degrees Celsius or Kelvin. The Kelvin is equal the Celsius plus 273.15. The last parameter, which we want to talk about it when we are talking about the gases, is the amount or the M. And this is the quantity of the gas present in the container. And the units, or we are measure the amount of the gas by gram or by moles. The gas properties depends on the conditions of temperature and pressure. So for example, the water turns to steam at 100 Celsius at the sea level, where the pressure is 1 atmospheric pressure. But what will happen if we go higher in a mountain, for example? So at higher altitude of 4,400 meters, the pressure will be less, will be decreased than 1 atmospheric pressure. And in this case, the water will turn to steam at 85 Celsius. To help make comparison between different gases and specify standard values of physical properties, we use standard temperature and pressure conditions are used, which called STP, standard temperature and pressure. The standard pressure is equal 1 atmospheric pressure, or in another unit, it's equal 760 millimeter mercury, or it's equal 10 to the exponent of 5 Pascal. For the temperature, the standard temperature, it is in Celsius. Temperature is equal 0 Celsius, which equal 273.15 Kelvin. The air is a mixture of gases. Of course, it is very important because the air is like we are surrounded by the air. So the air we breathe is a mixture of different gases, contains mostly nitrogen gas in the percentage of 78%, oxygen gas in the percentage of 21%, and a small amount of other gases which like approximately 1%. What we call the atmospheric pressure is actually the sum of partial pressure. Please take care about this word, the partial pressures. What is the meaning of the partial pressures? When I say the partial pressure of the gas, of one gas, it is the pressure that the gas would exert if it were the only gas in the container. So if I have a gas mixture of gases, so the partial pressure of the oxygen, it is the pressure that the gas would exert if it was the only gas in the container. What is the atmospheric pressure? This is the Earth, and we are living on the surface of the Earth. Above us, we have a column of gases because the Earth is surrounded by envelope of gas. So the atmospheric, the gas particles in the air, mostly oxygen and nitrogen, exert a pressure on us. This pressure, which all these gases exerted on us and all the living organisms on the Earth, it's called atmospheric pressure. Okay? In general, as we go higher, the atmospheric pressure, the column that above us, our heads, will decrease. While we go below the sea level, the atmospheric pressure will increase. Let's have a phenomena that we all noticed, that as we mountain or we ascend in an airplane, we feel that there is fewer like imbalance in our ears. So that's because we have imbalance in the pressure. There are fewer molecules per unit volume in air and the pressure drops. As we are in the airplane, the pressure will decrease. So you may feel the effect of the drop in pressure as a pain in your ears in the airplane. Why that will happen? Because the external pressure outside here, the external pressure will fall down, will decrease as we go on the mountain or we are in the airplane. The atmospheric pressure outside our body will drop, while the pressure of the air within your ear cavities remains the same. So inside your ear, inside your body, you will have higher pressure than outside. This creates imbalance in the pressure. The higher internal pressure causes your eardrum to bulge outward, causing pain. But within time, the excess of air within your ear's cavities escapes, equalizing the internal and external pressure and relieving the pain. We are going to talk about gas laws. We are going to talk about Dalton's law, Boyle's law, Charles' law, Avogadro's law, and Gay-Lussac. Also, please, again, I'm telling you, go to the Blackboard, weekly learning material, week 13. You will see that there is simulation. Please start to practice, follow the instructions that will give you understanding about the gas laws that we are going to talk about them in details in the class. The first law, it's Dalton's law. Dalton's law, in a very, very easy words, he said that if I have a container, this container contains mixture of gases. So in a mixture of two or more gases, the total pressure inside this container, it is equal to the sum of the partial pressure of the individual gases, as is this gas is individuals. So P total equal P1, P2, P3, while P1, P2, P3 are the partial pressures of each gas. Let's try to talk a little bit about the science and how we relate the gas about what's happening inside our bodies. We know that the alveoli, which is found in our lungs, it's like sacs, and it's filled with gases. Mostly, it is. We are going to talk about the carbon dioxide and oxygen, which is the most important gases. We inhale the air, but we take the oxygen to our blood. The partial pressure of the oxygen, I'm going to speak about the oxygen first. The partial pressure of the oxygen, the pressure of the oxygen inside the sacs, it's 100. But outside the lungs, outside our bodies, the pressure of the oxygen is 160. What will happen? That means that the oxygen will start to diffuse from the high concentration to the low concentration. Okay? And then it will start to diffuse within the blood. The blood, the heart, till it reaches the heart. The heart will pump the oxygenated blood. We call this blood as oxygenated blood till it will reach the tissues, the cells. The pressure of the blood, of the oxygen in the blood is 100, while the pressure of the oxygen inside the tissues, inside the cells, it is less than 30. So what will happen? The oxygen will diffuse from the high concentration from the blood to inside the cell. And the cells, all our cells need the oxygen to do something is called cellular respiration. Let's talk about the opposite. The carbon dioxide accumulated in the cells, then it will diffuse to the blood, then it will go to the heart. The heart will pump the deoxygenated, we call this is deoxygenated blood, to the alveoli. Let's see the pressure of the carbon dioxide in the alveoli is 40, while outside the pressure of the carbon dioxide or the concentration of the carbon dioxide it is 0.3. So what will happen? The carbon dioxide will diffuse to the outside from the high concentration to the low concentration. In the pressure of carbon dioxide and oxygen, that will be the gases will exchange in our bodies. Let's talk about Boyle's law. So we talked about Dalton's law. Now we are going to talk about Charles' law. Look to this slide. Look carefully to this picture. When we have a container and this container contains the volume is 200 millimeter, and we exerted a pressure on this on the gas found in this container, what will happen as we are increasing the pressure? As we increasing the pressure on the container, the volume started to decrease. So as the pressure on the gas increase, as the pressure will increase, what will happen? The volume will decrease, and that's Boyle's law. So Boyle's law said that if I have a container filled with gases and the temperature is constant and the number of moles is constant, and I exerted some pressure on this container, so the molecules of the gas, as we are increasing the pressure, the volume will decrease. How we explain this with the we are explaining the inhalation and exhalation by Boyle's law. Our lungs can expand. When the lungs expand, increase, the expand means that increase in the volume, what will happen to the pressure inside the lungs? The pressure inside the lungs will decrease. As the volume increase, the pressure will decrease. So the air will be flow or comes from outside to inside, from high pressure to low pressure, from high pressure outside the nose to the inside, from high pressure outside to low pressure inside the lungs. In the exhalation, which is the opposite, we will see that the lungs will decrease in the volume. When the lungs decrease in the volume, the pressure will increase inside the lungs. So when the pressure increase, it will the air will comes from inside to outside. Let's have another example, which is the scuba diving. As the diver goes down, as the diver goes deeper in the water, the atmospheric on the diver will be higher. So the atmospheric pressure will be more. We said that as we go below the sea level, the atmospheric pressure increase. That's why the diver carry air tank with compressed air that diver delivers air at the pressure that matches the external pressure at depth. Otherwise, the diver couldn't inhale the air. Let's have this example. A diver at 20 millimeter, that's he's under pressure or external pressure of 3 atmospheric pressure, and breathed the air under pressure at 3 atmospheric pressure from the tank. He's using his tank to inhale the air. When the diver decided to go from the deeper level to the surface of the sea, now the pressure will decrease. So when the diver comes up, his lungs at a higher pressure, it was under high pressure inside. So he must exhale while he is coming up to the surface. Otherwise, the air will try to explode from his body. Let's talk about another law, which is called Henry's law. In a very simple words, Henry's law make a relationship between the pressure and the gas solubility. He said that as we increase the pressure on the gas molecules, which is the gas, will be more soluble in the liquid. Think about the cans. The cans, it's a liquid and gas. The gas is dissolving in the liquid. So as we increase the pressure in the gas solubility will increase. As we decrease the pressure, we open the lid of the can, for example, so we decrease the pressure, so the solubility will decrease. Let's talk about the Charles law. Charles law make a relationship between the temperature and the volume. Let's see this example. We have a balloon, and the balloon contains number of molecules, and we put this balloon in an ice water. And the molecules started to move. So this is the volume of the balloon at the beginning. We took this balloon and changed it and put it in a boiling water, the same balloon. What will happen? As the temperature increased, the particles of the gas molecules started to move faster and collide with the wall of the balloon, and the volume of the balloon increased. So as the temperature increase, the volume will increase. This is Charles' law. As the temperature increase, the volume of the gas increase. Let's talk about Gay-Lussac law. Gay-Lussac law make a relationship between the temperature and the pressure. He said that if I have a container and this container contains particles of gases, and then I started to increase the pressure, increase the temperature for this gas. So in this case, as the temperature will increase, the pressure will increase. So higher temperature, collision frequency increase. So as we increase the temperature, the pressure will increase, and that's with one condition, that the volume and the amount of the gas are kept constant. The last law we want to discuss today, it is Avogadro's law. Avogadro's law, he said that if I have a container and this container contains particles of gases, amount of gas, which is the volume is 1 liter, and the number of moles is 1 mole. And the temperature and the pressure is constant. What will happen if I doubled the volume, the number of moles of the particles of the gases to be 2 moles instead of 1? So in the gas, as the number of moles increase, what happened to the volume? The volume increased. And that's in the conditions that the temperature and the pressure of the gas are kept constant. Thank you very much, and I would like to see you tomorrow in the class, and please prepare yourself by practicing on the simulation before you come to the class.